Welcome to Robots in Depth. Today I'm honored to have Alec here from Shaper Tools. The coolest overhand mill you've ever seen. But let's start where I usually start. How did you get into robotics, building mechatronic systems and all this?
Okay, well, thanks for having me, first of all. So I came into it kind of in a sudden change of direction. I was doing a PhD in computer science, totally unrelated stuff. I was doing computer graphics at MIT, and I ended up taking a leave of absence and getting an internship, and it was a really easy job, and I loved it because I actually had free time. And so I decided to pick up a hobby that I'd had for a long time. My grandfather left me his woodworking tools, so I started woodworking in the evenings, but I realized I was really bad at it, and I tried to make a picture frame, which is the simplest project ever. So 4 pieces of wood, 4 45-degree angles, at the corners. I got all the hand tools I needed. I penciled out my marks. I cut them in what looked approximately right. But sure enough, when I put the pieces together, the last little millimeter, or 32nd of an inch, there were gaps everywhere, and it just looked terrible, and I had to throw it away. I basically had an aha moment that night, realizing that that I could get really close, but I couldn't do that last bit, but a computer could maybe help me, and that led to the invention that was and is Shaper's first product, the Origin, and we're still trying to bring that out to the world. But yeah, for me, it was kind of funny. It was like I had been doing this PhD where I was paid to come up with ideas every day, and you beat your head against a wall and you try to think of good ideas and something comes out, but nothing that great. When I finally had some free time and I wasn't trying to, I came up with this idea that ended up totally changing my life and moving my whole direction into robotics, and that's where I am today.
I always say that vacuum cleaning your house or taking a bath are great for having ideas.
Absolutely.
I also like biking because it kind of distracts your brain. You have to focus on the biking.
It quiets some part of the brain.
Yeah, and the rest can come up, and you can always stop and write down your idea or do a sketch or call somebody or check something online. So.
Sometimes even at the company today, I'll take like an hour-long walk in the middle of the day, and I'll feel a little guilty because I'm on the clock and I'm getting paid for this hour. But I'm like, you know what? Actually, they're getting a good deal out of me for 1 hour because I'm like working through all these thoughts, and that's sometimes what you got to do.
Yeah, absolutely. There's times where you want to be wired in, and there's times where you want to unplug, and it's the combination of those two that gives you a good result. What I like about Shaper is that it is what I think is the road ahead for robotics, if not forever, at least for a very long time, and that is co-robotics. Augmenting people's skills with robotic skills, or the other way around, if you would like to say it that. If we should quickly describe Shaper to somebody that hasn't seen it operate, it is an overhand mill that you roughly guide, and then that the computer finally guides. So you follow the trace, and then roughly, and the computer then will do the precise movements.
Correct. Yeah, it'll adjust the cutting bit within about a half an inch. So if you get within a half an inch, it kind of slides over and nails it. And we call it autocorrect for your hands.
Yeah, and this is the robotics or electronics, mechatronics working together with humans to do a fully automated one with the robotic arm, and the cutter head at the end of the arm would be very expensive and also very limiting.
Yes.
But having it on the machine like this makes it so much better, huh?
Totally. And all you have to do is, we're here at a robotics conference, and you've got these amazing robots operating in their little pens, but any person standing around the booth, as they pick up a card and give it to somebody else as a business card or shake their hand, is doing 10 times more difficult robotics than any of the robots that they're demonstrating. And for a long time, I think the human hand is going to be the most powerful, most flexible robot there is, or not robot, most actuator there is. And so we're trying to just give it these extra abilities of super computerized precision so that you can take the things we're not good at and that a computer is good at, and get the best of both.
Yeah, which of course is exactly the beautiful synergy we were hoping for. So you had this idea and then you started to develop it. Can you talk a little bit about the early history there and what challenges did you face? How did you approach different problems?
Sure. Yeah, I mean, so I was pretty naive. Like I said, I was coming from a computer science background, but early on, I realized that there was real potential in this idea. So I quit my job, and I was still on leave from MIT, and I just lived off savings and tried to develop a first prototype, which was a one-axis correction. So it's the only one-axis CNC machine I've ever seen. And the idea was you had this router again that could slide left and right, and if you wanted to cut something, you pushed it around, and if there was some line you were following, as you moved along, it just moved left or right so it snapped to the line. And that meant if you were trying to do a circle, of course, you had to actually twist it around all the way, which was pretty difficult. But it was a long road to get there. I spent a lot of time calling up people who knew more about robots than me. Every single person I talked to said, it won't work, and here's why, but they all named a different reason. And so I figured, okay, well, no person thinks that, on average, it'll work, right? Because every piece of it, most people think will work. It's just everybody thinks that there's some problem. So I pushed ahead anyway. It was enabled by computer vision. The early days were, and many of the days leading up to today are about getting computer vision to really work in the real world, because I had sort of assumed, I read about computer vision like a established technology, how hard could it be? And then you realize it really doesn't work at all. The demos that you see are very controlled, special academic settings, whatever, generally speaking. And to actually get it to work in the real world is another kettle of fish. After I had a working prototype, I went back to MIT. I met my co-founder, Roland, and we switched to doing it under the auspices of our academic programs, though fortunately the IP was already all locked up because I had developed enough of it before I came there. And that's when we started the company. So that was the early days.
You started developing this now, and of course there were lots and lots of challenges in that. Anything you'd like? You had this one-dimensional thing.
Sure.
I understand now that it's two-dimensional.
It's actually three-dimensional.
It's three-dimensional?
Yeah. The third axis is mostly used just to engage. So if you're cutting a straight line, you start off on the side, and it's the cutting bit is retracted, so you're not cutting it. You move over to close enough, and then it'll plunge in, cut down, and then when you're done, it'll lift itself out.
So if you want to cut, for instance, letters, it would automatically go down and up when you go from K to M or whatever. Yeah. Is there also a plan to have a three-dimensional cutting of the actual material?
Yeah, definitely, it's on the list. I can't guarantee it'll happen by the time we ship. We do some 3D stuff for hole drilling right now. So if you want to cut, let's say you have a 1/4 inch cutter and you want to cut a 0.3 inch hole, we generate, you need to move in a circle to cut the size that you want. Instead of plunging down, cutting a circle, and then plunging down, and then cutting a circle, and then plunging down and cutting a circle, if you're doing 3 depth passes, we generate a spiral. So we spiral down, and then we get to the bottom, and then we do a finishing pass that polishes everything up. Then we go to the middle, and then we pull out. So that's a three-dimensional tool path.
Very interesting, very interesting. But I think that the 2D version is so versatile, and there's so much you can do with that. It's basically a laser cutter for anything, and you can cut wood, you can cut plastic, anything you can cut with an overhand with a router.
Yep.
Or a router, it's called in English, I think.
Yeah, a mill is generally referring to a metalworking stationary machine.
Can you talk a little bit about the material, thicknesses, dimensions, limitations, what can I actually cut?
Sure. Well, as you say, it's anything you can cut with a router. And just to talk to something you said earlier about 2D is already pretty good. I took the class before I left for this internship, so before I had the idea, at MIT, called How to Make Almost Anything by Professor Gershenfeld, which is a very famous class. Yeah. And I really remember him saying early on that, I know all of you came here because you want to work with 3D printers because they're so cool. And we're like, yeah, that's why we came pretty much. He's like, but I can tell you that you're going to spend most of your time on a laser cutter because most of the time 2D can get you everything you need. And also 3D is just way harder, to think about, to design, to work with. And that really stuck with me. And it was definitely an inspiration in creating this, the idea that really 2D, or I guess kind of 2.5D, where you can do like pockets and so on, is really, it's almost everything you see in the world around you is made from flat things that are then fit together.
And also the raw material is usually flat. So if we're supposed to do this on something that isn't flat, we're going to have a very challenging time. Yeah, but very interesting. Have you've of course tested this to do lots and lots of different things. What can you tell us about what you've done with it and the experiences you've drawn from doing that particular thing?
You mean as in different example projects we've built? Sure. We've thrown everything at it that we could possibly think of. In fact, initially I was convinced I was going to make all the furniture in my apartment using this tool, because that was kind of my original goal. And I was going to do it all with no metal, so no fasteners, just interlocking joints like Japanese woodworking. And so I moved to San Francisco from Los Angeles, and I purposely didn't buy any furniture. And for 6 months, I had no furniture because it took a lot longer to get the product working and then to be building things than I expected. My landlord gave me a couch, and I pulled a little camping table next to the couch, and that's where I ate all my meals for about 6 months. So I realized that was maybe a little too ambitious. In the end, I did build a queen bed frame with all the interlocking joints and so on. So that was kind of the first major scale, like huge project. Since then, we've been learning a lot about just different materials you can use. Obviously wood, but also plastic and soft metals like aluminum or brass, carbon fiber. We've been doing all kinds of different stuff, but it kind of works the way you'd expect. It's all much like just anything you could cut with a router.
What's the limitation? When it comes to wood, I guess what's the depth you can cut and stuff. Can you mention those limitations when it comes to wood and aluminum and stuff?
Sure. So for the depth, it's 1 3/4 inches is the amount of travel.
1 3/4 inches. So
Almost 2 inches. So
that's 40 millimeters? Something
maybe.
That'll be in the description of the video, but it's 40 millimeters.
Enough to cut a 2x4, if that
a substantial piece of wood anyway.
Yes, exactly. And then for other materials, obviously, we would love to be able to cut steel and so on, but we can't because, first of all, you want a cutting fluid for cutting steel, but second of all, it's still a hand tool, so you've got to have your own.
You can't feed with enough power.
Yeah. So like aluminum or something that's a hard material relative to wood anyway, we just take really shallow cuts so that we can not have too much material resistance.
How is that process automated? Do I have to follow the same path multiple times, or?
Yes, just like a hand router, you just follow the same path at different
And it does
depths.
the fine adjustment, of course.
Yes.
And then you can cut quite substantial pieces of aluminum too, I guess, because it's just following it more times, right?
Well, we've never cut more than like sheet aluminum, so I don't see any reason why you couldn't, but we haven't tested it, so I don't want to put myself
Somebody
out
out
there
there
on
is
the
going to
record.
be the first to try that when they get there. So if it works, they're going to be a hero, right?
Exactly.
If it doesn't work, they're going to be a support call.
Yeah, probably.
Because if you do things in plywood and aluminum, those are substantial materials. You could build a bed from these materials, and you can build, as we said, more or less anything, right?
Pretty much.
Yeah, and especially if you can go to carbon fiber too, which is an amazing material.
Really, it is, yeah.
Can you cut thicker carbon fiber, or is it also limited?
So far, we've cut a drone frame out of carbon fiber.
So a couple of millimeters thick is no problem,
not
right?
too thick. That's the only one we've done so far. But again, you could potentially do more.
And in worst case, you'll just have to trace the same route
Multiple
many
times. Yeah.
Yeah.
And just to state one more thing, which is about what we can cut. It's a lot of this is about taking the promise of, and forgive me if this is a robotic line, because I've said this before, but 3D printers seem so cool, but then you realize they're about making generally small plastic things, right? We want to take the coolness of that and the way that you can just digitally download a file and make it, and apply it to the things that you use in your real life. And wherever you're sitting in the world, friend, viewer, just look around your room, and almost everything you see was made with hand tools or with a CNC, and you could probably make with this tool.
Yeah, and you can make your own version that suits you better, and then just let your creativity go and just carry out whatever idea you have. And I love that. I
That's
love
the
that
goal.
part.
Yeah, it's gonna be fun. I hope I get more free time soon so I can actually use this tool. Cause
The only one that doesn't have time to use the tool is you, right?
Pretty much.
We
yeah.
get to play with it, and then we pester you for new features, so you never get to play with it.
Nope. We had a thing for a while. We tried to make every Friday was drop everything and cut day, but it's just
I think
not
that
enough
that's
time.
actually, if it was my company, I would call that very important corporate work, because dog fooding I'm big on dog fooding. I'm here in front of my own camera setup using my own I use the same microphones as the interviewee. I'm big on dog fooding. If you don't use your own product all the time, you don't understand it the way the customer does.
Well, I'll tell you one thing that taught us, which is that the reason we kind of have slowed down doing that is you end up spending almost all of your time in front of CAD designing what you're about to build, which isn't our product.
No.
And it makes us realize that no matter how easy we make it to make something, there's a huge unsolved problem, which is making it easy to design something, precisely.
Yeah, that's a task for somebody out there to
Somebody,
make that easy.
please solve that for us.
What kind of, we haven't mentioned that actually. So I draw this in my CAD software of some sort. Which softwares do you usually use yourself, and what kind of files? How do I get my design into the machine?
Sure. Well, so the machine accepts 2D vector files right now. So 3D information you have to kind of add on yourself. So if you get a square with a smaller square, and you know that you're supposed to pocket out the inside and then cut out the outside, it's up to you to punch in, I'm cutting the outside on the tool. But any vector file you can just drop on the tool. You can use a USB thing.
So then we draw this vector, we draw the design, and we get the vector file, and it just goes to the machine, and then we put the tape out. When we put the tape out on the surface we're going to work on, can the machine tell us when we've put enough there and when we're done, or areas where we need to? Can you talk a bit about how we put the tape out?
Sure. So the workflow right now is you put the tape on the material, and you don't need a ton, and it doesn't need to be in any particular pattern. It doesn't need to be in like perfect straight lines or anything. It just needs to cover it, because again, the camera's using it as landmarks, not as instructions. It's just high contrast features that it can pick up. Then when you put the tool on it and it's a new area, it'll start scanning in the workpiece. So as it sees new areas of the wood that it's never seen before, they'll get added to the map. And that's pretty much SLAM. Probably a lot of your viewers know simultaneous localization and mapping. So the map gets built up. Then when you're done with the map, then you say, okay, I want to place this vector file, and you get to register it onto that map using the tool kind of like a mouse. This is hard to describe in words, but it's really cool to see. Because you have a map of the particular piece of material, let's say wood, that you're cutting, you actually see the edge of the board or a knot or something you've already cut before. And so if you're overlaying some design, like let's say you're cutting out the outline of the United States, you'll see that vector file kind of transparently rendered on top of the actual wood.
Cool.
And when it lines up somewhere good, you say, okay, that's great, click, and then everything is registered to the particular piece of wood, and you can start cutting it.
Yeah, so that allows you, so if you want to cut 10 things out of a board, you can experiment with how best to place them to use as little wood as possible.
Yeah, it ends up getting you so many benefits. And this is in contrast to, let's say, like a motion tracking system where you have a camera on a pillar or something tracking the material, tracking the tool. In that world, everything is registered relative to like the space of the tracker, or on a CNC machine, everything is relative to the origin of the bed. Having everything registered to the material gets you all these benefits, like if the material moves around, which it does if you didn't clamp it very well or whatever, your designs move too, everything's fine. You can also just put a piece of wood on a shelf and then finish it the next day, and everything will come right back to where it was. So that ends up being a kind of huge, unexpected benefit of using this computer vision and tape-based system.
Very interesting. We're so much looking forward to having this in our hands and starting to do tests and experimentations. And finally, you'll have some furniture, I guess.
Yeah, I hope so. Yeah.
You're fed up with a borrowed sofa and the camping table by now, I guess.
Yep, very much so. We want to put IKEA out of business.
Thank you very much for taking the time to do an interview.
My pleasure.
I hope you liked this episode of Robots in Depth. I'm proud to produce Robots in Depth with the support of the sponsors, Carbon Robotics and Aptomica. Carbon Robotics is redefining the relationship between humans and machines by making advanced automation dramatically more accessible, with low-cost robotic arms, integrated vision, and a powerful task intelligence engine that automates tasks no human was born to do. Carbon Robotics is proud to support Robots in Depth in their goal to elevate the global robotics ecosystem. Aptomica rents anything in modular robotics. Dream, rent, build. Visit aptomica.com to connect. If you like this episode, tell your friends, give us a thumbs up, subscribe and turn on your notifications. I am Per Sherboy, and I'll see you next week in another episode of Robots in Depth.